Let's talk about a structure called a trie. Every once in a while, you'll run across a structure. If you were to do like a Google search engine, you'd wanna put your data into the structure so you can do spelling corrections and stuff like that. That would be an example of a usage. Um, let's see. It was invented in the 1960s by a French guy, so the true pronunciation is tree. But obviously, if we called it a tree, that would be confusing for all the other trees. So, yeah, let's just call it a trie so there's no confusion. All right, so I have a trivial trie here with a couple of words in it. And to store this on each node, there's an array or a vector of character and pointer pairs. And those character and pointer pairs point to another node, and that, and so on down to the final node, or the final pair that has a null character and a null pointer. There's no flag. That is the end of the word. So people saying that there's a flag in here, actually wrong. I mean, the null character itself is the flag. The data is the flag. And another thing I think I've heard people get wrong is they've insisted that you need to use a map structure on the nodes. No, no. In fact, the map underperforms the vector for trivial sets. So because you have a maximum of whatever 20 characters, your map is going to underperform the vector. But it's like I said, it's a trivial set. So in your application, you have to make a decision as to whether or not that matters. And the convenience of a map is nice. Now getting back to this, each node has an array of character pointer pairs, and so every word is broken into all these character pointer pairs. And so your first word, A, R, T, null character, right? So that's put into the structure. Then your next one, A, R, E, null character is also in the structure. Your next word, A, R, K, null character. And then Abu, A, B, U, null character. Now that's how we've stored it. That's what it looks like. This is just an illustration. The C code would be a vector or an array. If you want to get lazy, I guess you could use a map. I think I've used a map last time, but that's going to underperform the straight array, just because on the index, when it searches the index of the map, it's going to use a binary search, and that binary search will take like 100 searches on the trivial set of three. It'll just underperform something horrible if you were in a situation where this was like in a phone switch. So anyway, but there's your structure. And this allows you to do spelling corrections. So when you're searching for a string, you can actually reverse two characters. That would be like a transposition error. You can add an extra character by when you search the node. You can go through and look at all the other characters on the node. And you can also delete a character from the end and look for those null characters and find your other potential matches for that word. So even if the word isn't in the set, you can still find potential closest matches. Let's look at a spelling correction on our try. Okay, so we have our try here. Let's look for the word AKU. Okay, so we have the A in the first node and the root node, and that root node points to another node with the R and the B, but we didn't find the character we were looking for. What we can do is we can actually go back to our string and go back to the node and say, well, okay, we can look for maybe an incorrect character. So we matched on the A on the root node, so let's go ahead and go to the next node. And then let's assume we typed K where maybe we meant R. Well, we don't have a U under R, so no, that's probably not what we meant. But then when we go and look at the B in the same node, we see that, yeah, that one has a U under it, so maybe that's what we meant. Maybe ABU is what we meant. And so that would be what we would present as maybe a spelling correction. Well, that should be enough to get you started with the Trie structure for your spelling correction or actually matching words to data. If you go out and you watch other YouTube videos and they start mentioning that there's a flag in this structure, you know they've never coded this. They're literally repeating what they've learned by watching other YouTubes. There's no flag. The data itself is a flag. If they insist that you use like a map structure, that's another flag. They don't have any real world coding experience because, that's a structure for something with more data. I mean, you can't have one, two, three, even 20 pieces of data. It'll never be as fast as your list or an array. Although it doesn't matter for the speed. It really doesn't. Usually, you can just go ahead and use a map. There is a convenience. But when people make those statements, it's just it's a red flag. It shows that they don't have a lot of coding experience. Anyway, I hope I've presented this concept well, and good luck with your coding. Thank you.